A rectangle has one side of length x and another side of length 2x. How much larger is the area of the rectangle than the largest circle that can fit inside the rectangle? Okay, this one's a little more involved, so we'll draw this one out. So here, let's do our drawing right over here. So we have a rectangle that has one side of length x and another of side of length 2x. So I'm going to call this side x and this side 2x. Then it's asking me how much larger is the area of the rectangle than the area of the largest circle that can fit inside the rectangle. So the largest circle that can fit inside the rectangle is going to look like this. And if you'll excuse my terrible drawing, this is supposed to be touching at one point up at the top right here. Hopefully you guys see that. Basically what we're looking for is the area of the rectangle minus the area of the circle. So we're looking for the area of the rectangle minus the area of the circle, because that's going to tell us how much larger the area of the rectangle is than the area of the circle. So the circle is right here. It's going to have some radius going down like this. And if you look carefully, the radius of this circle is actually going to be exactly half of this length right here. This is going to be 1/2 x. That's what the area. That's what the radius of the circle is going to be. And that's essentially, we have all the information we need now. So in this case, the area of the rectangle is going to be equal to base times height, or you can do length times width. I'll just do base times height, minus the area of the circle, which is going to be pi times radius squared, just like that. And now we can plug everything in. So in this case, your base is equal to 2x, and your height is going to be equal to x, minus pi times your radius, which is 1/2 x. So I'll just call it x over 2, but that's the same as saying 1/2 x squared. And now we multiply. So this is going to give us 2x squared minus pi. I'm going to leave it in a different form, or in a slightly different form here. And then I'm going to do x squared over 2 squared, which is equal to 4, like that. And this this actually works out really well for us, because we can actually take out some common factors here. So the first thing we can take out of here is x squared. X squared is something we can immediately remove because it is part of both terms. So x squared is going to come out, and you're going to be left with 2 minus pi times 1/4, or pi over 4, just like that. And does this look like any of our answer choices here? It does not. It does not look like any of our answer choices here, although we do have 2 with x squareds, an x squared term on the outside. But maybe what we can do is try simplifying the inside a little bit. Maybe we can try simplifying the inside, or rearranging it. And I can do that very simply by just leaving the x squared as is, and on the inside I'll just do a subtraction. So 2 is going to be equal to 4 over, not 4, excuse me, is going to be equal to 8 over 4. You know what, I'm going to rewrite that. 8 over 4 minus pi over 4, just like that. And now I can simplify it. So I'll get x squared, and on top I'll get 8 minus pi over 4. And this actually looks exactly like one of our answer choices. It's going to be answer choice A, because in this case they've just reversed the terms, but the x squared can be on either the inside, or in the front, or on the back, because the order in which you multiply does not matter in this case. So the x squared will be distributed no matter how you distribute it. So the correct answer in this case is A.